Yeah, Joshua is a Phoenix LiveView and Elixir zealot. He's an instructor at LiveView Mastery, a semi-pro poker player, founder and CEO at Or Equals. Everybody give it up for Joshua. There you go.
Thank you for the pre-clap. That is very kind. So my claim to fame is I've been working at a software consultancy that I started about 3.5 years ago called Or Equals, and our biggest client is a grocery delivery service called Local Fair Jacks in Jacksonville, Florida. And they tasked us with the option, and we took the option, to build them a routing software. So we essentially built them a full stack application where people can sign up for a subscription for vegetables and meats each week or monthly for locally sourced produce from local farmers. And they were using some off-the-shelf software that they spent like 75 grand for the initial license to be able to route their drivers. And essentially they tasked us with bringing that in-house. And this project was about a 5-month build. We started it in November of last year, and pretty much it launched like 3 days ago while I was on the way here. And that's essentially what I want to get at today is I want to talk about geocoding. The thing is, you know, a lot of you work in healthcare or accounting. So geocoding is essentially taking an address and turning it into a latitude and longitude. So that's really not interesting to necessarily everybody in the room. So what I really want to get at is my goal for this presentation is much more ambitious. I want to try and eliminate imposter syndrome in our industry. And the way we're going to do that is through process. So remember, I'm driving up. We did a 5-month build of this thing. They're using this thing for the first time, and this is a text message that I got from the CEO of Local Fair Jacks. Too smooth so far, 9:31 a.m., 10:23 a.m. Hey, man, we really did our thing with, this is me to him. We really did our thing with the QA, encountered all the problems up front. I agree. I can't believe how smooth it has been. And then by 1 p.m., pretty much one of the drivers finished their routes, and they said, routing launch looks to be a huge success, first route completed. And essentially, this presentation is about geocoding, but deeper than that, I want this presentation to be a meditation on the nature of software development and software engineering. So I have 2 goals with this presentation. I want to teach you about geocoding in Elixir and in Phoenix LiveView, but in addition to that, I want to give you a repeatable breakdown, an approach to building software where you can end up with a result where you're literally driving to a conference. Like I spent like an hour in Jacksonville just to make sure nothing went wrong, but essentially they had a fleet of drivers. They're delivering thousands of deliveries a week and I had 100% confidence in building it, and the reason why is because I knew the problems that we were solving, and I knew that we had solved them accurately and precisely. So a little bit about me before we get started. My name is Joshua Plicque. I have this software consultancy, Or Equals. I also make YouTube videos about LiveView and Elixir on YouTube, and it's called LiveView Mastery. So let's just talk about consulting and then what Local Fair Jacks approached me about 6 months ago. They said, hey, we need a mobile app for our drivers to be able to deliver produce. And the problem with the world is that the world will arrive at your doorstep with half-baked solutions. A lot of the time, people start with a solution, and the reason why we end up, so I think it was Ben yesterday talking about spending months building something and it's okay to throw it away. I disagree with that. I don't think it's correct to build something and to throw it away. I believe that it's correct to get it right the first time. And so the purpose of this presentation is we're going to talk about geocoding, and we're going to talk about how do you get it right? How do you build something for 5 months and be able to drive up to a conference while it's being deployed? So essentially, when people come to you with their half-baked solutions, you want to ignore that and you want to uncover their problem. So 6 years ago, I was working at a legal practice management startup, and it's called ZenCase. And essentially all it does is it effectively allows law firms to bill their clients, generate documents, effectively runs their whole company. And 6 years ago, I was sitting in a meeting, the old CEO, the guy who is the managing partner of the law firm, he's a guy named TJ. And TJ is someone who wears a blazer to every meeting, bleached white shirt, starched. It's almost when he walks in the room, he's glowing. And he has a nickname, it's called Hurricane. And the reason why he's called Hurricane, because he walks into meetings and he's just dictating everything. He's the managing partner of his law firm. He's the CEO of this startup, and the law firm is funding the startup. So eventually things got too much for him to handle running 2 companies, and he hired a CEO guy named Derek. So Derek is the new CEO of Zencase. At this point, I was the first employee, and I was the head of engineering at this time. And 2 weeks into Derek's tenure, Hurricane walks into the meeting with me and Derek, and he's like, hey man, we need a QuickBooks integration, and we need an integration with LawPay, because the Stripe integration we have, it's 2.9% that they charge us, but if we use LawPay, it'll be 1.75%. And then Derek said, stop. Stop giving me your solutions. Give me your problems. And the reason why that was so profound at the time is because Derek, his claim to fame is he sold, his name is Derek Mercer, he sold a startup called RecruitMax in 2009 for $150 million. So everything I'm talking about with this problem solution thing, here I am sitting in this room with this guy who sold his startup for 9 figures, and he's now the new CEO of my company, and he's echoing the things that I believe in. And when we start with problems before we end up with solutions, this is how we end up with the result of, I can't believe how smooth it has been. So a little bit about me. I want to talk about essentially how is that done. It's essentially the engineering method, and there's really 3 steps, and it's really simple. Step 1, you want to explicitly state the problem. Number 2, list your assumptions. And then number 3, then and only then do you design your solution. Now, you may be seeing this slide and be like, okay, that's pretty obvious. Okay, why is this so profound? This is so profound because when I studied mechanical engineering and I spent 5 years doing that, we would actually lose points on tests and quizzes and homework if we got everything right, but we didn't actually explicitly state the problem, list the assumptions before we got to our solution. So the reason why I'm mentioning all this is because this is how we solve imposter syndrome. Mechanical engineering has been around for a long time. Chemical engineering has been around for a long time. I'm here to deliver to our field, which has no regulation, no standards. This is how it's done. This is how the other engineering disciplines get it done. And the reason why I feel so confident as a software engineer is because I have this process of explicitly stating the problem, listing your assumptions, and ending up with your solution. So we're actually going to go through geocoding, and we're going to put our engineering process to use, and we're going to get precise, accurate solutions. So what is geocoding? Geocoding is taking it sounds like my mic is dead. Geocoding is taking an address and converting them into latitude and longitude coordinates. So this is the sign-up process for local fair jacks, where they select what? Thank you. All right, perfect. All right. Yeah, so in the sign-up process, people can select what produce subscription they want, and then they have add-ons where, hey, I want to get fresh laid eggs with my delivery, chicken breast, blah, 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 whatever. You get to this 4th step, and you put in your email and your first name, your last name, and then you put in your address information. Now, by the time someone goes through this 4-step process, we actually are using an Ecto multi to process everything here. It's this just giant function that, hey, did they have a coupon code? Did they have add-ons? Did they select any allergies? Did they decide to tip the driver? It's about a dozen or like 20 different things that we're saving to the database all at one time. And so if you've not encountered an Ecto multi allows you to have a database transaction where essentially, remember, we're doing 12 things at a time. So say the database transaction at step number 10 fails, it'll actually revert all the way back, all your data back to the original state between all those 10 data changes in front. So the problem here is to explicitly state the problem, to use our new engineering process, we need their address geocoded to Latin long coordinates for delivery. The reason why is because we need the Latin long to be able to draw it on a map. This is the reason why geocoding is important. Step 2, assumptions. We absolutely need geocoding to occur because otherwise we can't deliver the stuff. Notably, we don't need it immediately. When they're signing up, we just need to know what their package is and what add-ons they have, but we don't need to know, they don't need to have a Latin long at that immediate moment. Notably, it's making an API call to a separate service, Google's Geocoding API, and we don't want to execute our Ecto multi to reverse on API failure. So essentially the solution would be to background it, right? Like that's the obvious solution. So, but should we use a task? So the problem with the task is that it's gonna try 3 times instantly. What if the Geocoding API has an outage and it's actually down for 2 or 3 hours? Well, that means we need a different solution. And this is the reason why having our assumptions is really important. Our assumptions is that we don't need it immediately. It's making an API call, so that means an API call can go down. So we don't want to use a task because a task is going to try it 3 times, boom, it fails, and then we lose that thing. But remember, we need it. We need it geocoded. So we use the tool called Oban. And so to most of the people in this room, this is a very seems like a very high-level room. This is very obvious, right? Like, okay, yeah, just use Oban. But by using this engineering process, we can arrive at this solution with confidence. And so let me just show you the slide again of the Ecto multi with the 12 different steps. And then I'm going to zoom in on the section where we're actually enqueuing the location worker. I'm just going to just show you the code of when someone signs up, we're enqueuing, we're saving all these things to the database, and we're geoencoding their location. So the way this works is we take the payload of the member, and then we're passing it to a geolocation worker, which is an Oban worker, and then we're inserting it into Oban, and then Oban's now responsible for maintaining consistency. And the reason why we chose Oban was because, remember, we absolutely need these addresses geocoded. So this is what the worker looks like, where we're inserting records into the database, and we are getting coordinates, and then finally we're actually using this, that's calling a function on, at the beginning of the case statement, locations get mapped for. It's actually calling this external library. It's a very thin library called Geocoder, where you just pass it a location, whether it be an address in Paris, an address in Chattanooga, and what that looks like is, so shout out to whoever wrote that library. I hope you're here, that'd be cool. It's provided a lot of value for us. So essentially geocoder.call, you pass it a location, and it gives you an OK tuple with coordinates. And there's the opposite to geocoding is reverse geoencoding, where you can pass it a Latin long, and it's going to give you an address. So Geocoder comes out of the box with support for 3 different providers: Google Maps, OpenCage data, which I've never used, and OpenStreetMaps. So OpenStreetMaps is, so this is specifically for the people who are going to be doing geocoding in the future. OpenStreetMaps is very unreliable. It uses an API that's fairly unmaintained. It's called Nominitim. And Nominitim is unmaintained to the point where it only allows you to make, it throttles your API requests to 1 at a time. So it's effectively unuseful. It's almost unusable in production. And so when we ran this against like 11,000 of their customers, we actually had an 83% success rate. So 17% of the addresses were unable to be geo-encoded. We switched to the Google Maps API, and 100% of the addresses were encoded. So I would not advise anybody who's going to do geocoding to use the Nominitim API. So what's the heuristic from this? The heuristic from this, which is very obvious to the experienced people in the room, is that network calls, file I/O, emails, anything that can take longer than 300 milliseconds should probably be backgrounded. And once again, that's obvious. But by using this 3-step process of being an engineer, there's actually an additional part of that form when you sign up. You actually sign up with your credit card. And so let's go through our process again. We need their payment information at sign up so that we can charge them. And now this is where the assumptions change the nature of our solution. Here's the assumptions. If all their info is valid, but the payment doesn't go through, they can't sign up. We don't need people in the database who we can't charge because, hey, if we can't charge them, we can't make money. We can't allow a bad card to go through sign up. This is additionally making an API call to an API called authorize.net. We don't want to save the data and have to reverse, like we don't want to save the person's data to the database, it failed the credit card and have to like remove that data from the database. So that means our solution is going to be different. So here we have the same, remember that God function that I showed you with like 12 different things that it's doing? It's also saving the credit card. And so the solution here, we're breaking the heuristic. Anything that takes longer than 300 milliseconds or is an API call, that heuristic, which was obvious, we're gonna now confidently break that heuristic because we need to do the API call in the web request, because if the person's credit card is invalid, we don't want to save them to the database. So by using this 3-step method, by always starting with your problem as opposed to just hacking away, you can now follow the rules, you can follow the heuristic of backgrounding things with confidence, but you can also break the rules with confidence. And then finally, I just wanted to show you that in the app, they can change their address, and it's also going to do an upsert in the database. So an upsert, for those that don't know, it's going to, if the person doesn't have a location in the database, it's going to create it. And then if they already have an existing one, it's going to update it. So it's kind of like it works on create and it works on update. So let's get back. Let's just jump. So now we're going to do just a deep dive into geoencoding. So how do we draw the markers on the map? So there's a open source JavaScript library called Leaflet.js. And Leaflet.js is kind of like the industry standard for drawing maps in JavaScript in the browser. And the end result kind of looks like this, where you can have all your map markers and everybody's pretty much knows at what specific location. Remember, this is the reason why we needed the Latin long, to be able to draw these markers on the map. So the way that looks, and this is where we're going to jump into live view. So here's what the mount function looks like for that map that we just looked at. And I have this line highlighted, this push event. So this is in the live view API push event. So live view is not just something that you can just use Phoenix update and Phoenix submit. You can actually by hand send events from the backend to the front end. So in the live view API, you can push an event. So there's this init map event where we're actually sending the payload of all the deliveries to the front end. And then on the front end, there's a Phoenix hook. So in live view, Phoenix hooks handle custom client-side JavaScript when an element is added, updated, or removed from the server. A hook object may be provided via PHX hook, and it allows you to hook to the live view lifecycle. So there's the mounted callback, there's the updated and destroyed. The one that you really care about most when you're using Phoenix hooks is the mounted callback. The reason why is because you want the live view JavaScript to have hydrated the DOM before you're actually trying to send events to live view. Because if you do that, if you try and send events to live view before it's active, this is the reason why this API is so powerful, is because essentially it'll allow you to run your JavaScript at the correct time after live view is active on the page. So the Phoenix hook kind of looks like this. This first 2 lines of code, PHX hook, we send the initial delivery route hook where, remember in that live view, that init map event, it's hitting the delivery route hook, and this is what that hook looks like right here. So that hook looks like the following, where it's grabbing the map on the page, and remember I live in Jacksonville, Florida, so it's centering the map on Jacksonville, Florida, setting a zoom on it, and it's effectively drawing the map on the page. And the coolest part of this, and so L right here is short for leaflet. Remember the library is called leaflet. And the magic happens here where it's actually drawing all the markers on the page. I'm going to show you what that function looks like. So draw map markers. So at this point, it's actually icon size, icon anchor. It's actually putting the map icon onto the page using L.marker. Remember, L is short for leaflet. And this code's not necessarily that interesting, but what I really wanted to show you guys is the technique of actually doing an interop from the backend with live view. Is you do a push event on the backend, you use a PHX hook on the front end, and during the mounted callback, we are actually looping over all the data that we're pushing by hand from the backend, and we're drawing all the map markers. So leaflet is very well documented, so if you ever have to do this, you can refer to this presentation, but you can also look at the leaflet guides. And then in addition to that initial route hook, we also have the update map hook, because something else that we have support for in the geocoding feature set is the ability to change the sort order on the page. So like say, you have a driver has a collection of 70 deliveries for a day. You can change delivery number 2 to delivery number 1. And then at that point, we need to redraw all the routes on the page. And so that kind of looks like this. It's the same technique, mounted callback. We do update map. And then the line that's highlighted, this is the important part, where we loop over all the markers. We kind of remove all the current markers, and then we redraw them. So this is not necessarily like the coolest code, but because of the lack of volume of data that we're working with, we're able to get away with just, hey, we're just gonna remove all the markers and then we're gonna draw them back on the map. So the drag sort uses the same technique. So the drag sort is kind of what I was telling you about. So we have Maya Sutherland here. She was the first delivery. And then you can do a drag and drop here and move her from delivery number 1 to delivery number 2. And then the map will redraw. And then number 1 will become number 2 and number 2 will become number 1. So we're using a sortable JS library. And it's the exact same technique with PHX hook. And so that looks like this, where we have a PHX hook called init sorting. And it looks like this, where we import the sortable JS library and we give it a drag class. And notably, just like we were able to talk from the back end to the front end by hand with the push event, LiveView.js has this excellent little function called push event, where when we initially draw when we initially load sortable on the page, we actually send a push event update sorting from the front end to the back end with the IDs of all the elements. So essentially what we're doing is we're doing LiveView by hand as opposed to relying on out-of-the-box PHX validate or PHX submit. And it's very easy to do because it's just really just one line of code. From the back end, you can send a custom event to the front end, handle it with a hook, and then within a hook, you can send a custom event to the back end. And so the name of this event is update-sorting. As you can see on that push event, boom, you jump. Here's the back end code. Now the back end code here, I'm not very proud of. It kind of is inefficient in the sense that, it's kind of ugly code and yeah, it's kind of dumb, but essentially, when you initially load the sort order, it actually sends an event to the back end to return all the sort orders on the front end, and then in that push patch there, the highlighted line of code, it's actually going to re-render the DOM. So every time you move, every time you move a sort from, say Madeline Coble, number 2, if you move her from 2 to 1, it's going to send that event from the Phoenix hook to the backend. The backend is then going to handle the sort order, and then it's going to re-render the page. And so it all just works. In production, it works like clockwork. So how about these lines? The way you generate these lines is Leaflet doesn't come out of the box with support for the fact that, hey, we want to be able to show that if you're going from position 1 to position 2, what is the line of that so that you can actually visualize, the routing manager can visualize the path of the driver. So there's a library for that called Leaflet Routing Machine. Leaflet Routing Machine is a plug-in to Leaflet where it actually gives you routing support where you can get these awesome lines. And so here's the code for that. Now, the coolest part of this code is that there's this chunked waypoints function right here. So chunked waypoints is interesting because if we're dragging on the page, it would really suck if we had to keep doing an API call for every single marker on the page. So say there were 70 markers on the page earlier, and say whenever we drag a new location, if we're having to trigger 70 API calls, that's going to be very inefficient. And what chunked waypoints does is the majority of the routing software out there is you can send it a collection of 25 waypoints at a time, and it'll actually give you the lines all at once. So instead of having to do 70 API calls, you can do 2 or 3 API calls. So as we kind of walk through this code, it's doing a L, remember, of course, that's Leaflet. It's adding a routing control. That's the name of that line. So it's essentially looping over all the waypoints, and it's just drawing lines between each of the markers. In addition to that, to be able to handle the different chunks, remember we're handling 25 waypoints at a time, we kind of have this code right here where this logic creates an additional control to connect every set of chunked waypoints. So from chunk 1 to 25, this code kind of handles going from 25 to 26 and then going from 50 to 51. So yeah, essentially using Leaflet and Leaflet Routing Machine, using Phoenix hooks, pushing events from the back end to the front end, and re-rendering the page every time we make a change to the sorting, we're able to very quickly be able to define a route for each driver. So the very next feature that we built is mission control. So mission control is really cool because it effectively is a live representation of where the drivers are at each time. And so here's the mobile app of what that looks like. So this is my routes, and whenever I click start or update, it's actually going to change the state of whether that shows checked if it's delivered, or there's like a nice bouncing truck when it's in progress, which is fun. I love that thing. So the beauty of how this works, the reason how we're doing live updates is really simple. Phoenix PubSub. So here's the update endpoint. We have a singular point in the system. This is the update controller coming from the mobile app. So when you click complete or start on a route, what it does is it broadcasts an update to mission control. So coming from the mobile app, we're updating the status of the delivery, and notably, this part right here is where we're actually broadcasting an update to mission control. And the beauty of Phoenix PubSub is it's really like 5 or 6, 7 lines of code. So Phoenix PubSub, on the mission control mount step, we actually have a subscribe function where we subscribe to the mission control topic. All it is just a string. And then we have the broadcast function. So you just saw that in the delivery controller. So here's the mission control actual mount callback, where here we are subscribing to the PubSub for mission control. So here you have, like when you click on the mobile app, we're publishing an event, and then the mission control page, it just sits there and it's subscribed to updates coming from the mobile app. And the way that works is you just add a handle info callback, update mission control lists, and all it does is it just grabs the new deliveries out of the database and it updates the state of the DOM. And here you have something that, like, I don't know, has anyone else used PubSub? Like, it's like shockingly simple. Like, it's almost like I feel like I should be paying somebody to use it. Like, it's so good and so easy to use. And so this is it in production. So this is a picture of them showing like, oh, yo, look, we got live updates. And like, this took us like 45 minutes to do. Like, this is like, it's amazing, right? Like, this is the live in live view. Like, the live in live view is like almost like something you don't even have to consider. So the mobile app updates, this is where I actually made a considerable mistake in my architecture for this. So the mobile app, the reason why they wanted a mobile app is because what if they make a change in the office, like say they removed the fact that you're not going to you call into the office, hey man, I don't want my cheese, like I'm feeling lactose intolerant, I don't want my cheese this week, and you can call that into the office. They can update your bag where you're not going to get your cheese. And so the way I actually originally designed this was very over-engineered, where you can add an item, it's going to trigger a routing list update. I was going to use PubSub like crazy, like 13 to 15 different areas of the system that's going to do a PubSub broadcast, and we're going to send an event to the WebSocket for the mobile app. But sometimes simple is better. Sometimes simple and unsexy is better. And so we're going to go through our process again. You're going to use our method of getting rid of imposter syndrome. Problem, drivers need live updates in case things change. So my first solution to that was, hey, we're gonna use PubSub. The problem with that is it's a brittle solution. Like say they rename an item, it goes from artisan cheese each delivery to cheese each delivery. Like, because we have so many entry points, software is always inevitably going to change. And so I have essentially 13 or 15, every time something new gets added to the system, I'm gonna have to add a new PubSub broadcast. So that means it's a bad solution. So what are my assumptions? The data in the mobile app needs to reload assertively. Setting PubSub everywhere is going to be brittle, and the driver is going to be taking over 200 actions in the app a day. So these drivers have about 70 to 80 deliveries. They're going to be clicking the start button. They're going to be clicking the complete button. They're going to be going to Google Maps and coming back. And I was just thinking, you know, if I just make sure every time they're in the app, they have this current state of the data in the back end, just make an API call every time they take any action in the app. So this is not as cool, it's not as sexy as PubSub, but this is something that effectively will work forever. And this is so cheap. Like when in Phoenix, every request gets its own process. Like we have microsecond response times, and this is kind of like, we can do kind of like not sexy solutions like this without a very high cost. And then finally, to build a mobile app, I just wanted to make a mention of this tool. I'm not being sponsored for this. There's a tool called Flutter Flow where it's like a low-code tool. We pretty much did almost no code for the mobile app at all. Essentially, it was just a drag-and-drop interface. You can do drag-and-drop for your API calls, and this is kind of what that looks like. So by the end of this, we did I sent an email to the CEO of Local Fair Jacks, and I said, hey, like, we need to do a production QA plan. We need to, the nature of this email is really not that important. It's just important to test your code and make sure that it works. And ultimately, by the end of this, we ended up with a launch that went very smooth. And the reason why is because of the 3-step process that I showed you. We were able to, instead of people giving us solutions, and you may and gamble on being able to solve their problems, the goals of this presentation were to show you geocoding and Elixir and Phoenix Live View, techniques that we used to be able to do that, and the reputable engineering process that I learned. That was 5 years of engineering school in 15 seconds. Yeah, and it's really that profound. It's that simple, but if you just force yourself, like I do it by habit now because of being literally losing points, getting everything right on an exam, and not stating my assumptions, I lost points. If you use these techniques, if you use this one simple technique, this one weird trick, you can be an engineer forever. You can approach your engineering. You can have the confidence to be able to drive it to a conference, having a 5-month build for a piece of software to build this routing system, and know that it's going to work. And I hope that by the end of this presentation, I know many of you don't care about geocoding, but I hope you do care about engineering, and I hope that you use that 3-step process to increase your confidence in this career and ensure that you have accurate and precise solutions. Thank you.